So how do I go about figuring out if 4 comma 7 is truly a solution to that system of equations? Plug what in where? Bingo! 4 in for x, 7 in for y. Okay? And if it is a solution, we will get true statements all around. So if I go 3 times 4 plus 4 times 7, 3 times 4 is 12. 4 times 7 is 28. 12 plus 28 is 40. Is 40 equal to negative 17? No. So right then and there, it's not a solution because it's not a true statement. So no, it is not. Not a solution. Love it. And if it were true in that one, then we would have had to check it in the other one. And if it's true in both, then it is. If it's false in one, it's not. Love it. Okay? So today, oh, that kind of changed. I don't remember how that changed, but okay. That wasn't the font that I chose for it. All right. Okay. We're going to talk about 3x3 systems of equations. So that's 3 equations with 3 unknowns. So now what we have is something called an ordered triple. And an ordered triple looks like a point, but it's got 3 parts to it now. And it's of the form x, comma, y, comma, z, or alphabetical order still, just like in a point. Okay? So if your problem is x, y, z, your ordered triple is just that, x, comma, y, comma, z. If your problem is a, b, c, then it's a, comma, b, comma, c, and so on and so forth. Okay? So is the ordered triple a solution to the system? How would we find that out? How would we figure out if that ordered triple is a solution to the system? Plug what in where? Love it. Let's do it. Okay? And we got to do it in all 3 until we get a false. If we get a false, we can stop. But if we keep getting true sentence or true statements, we got to keep going. Okay? So let's start with the first one. 2 times 7 plus 5 times 1 plus 3 times negative 3. So that's 7. That's 1. That's negative 3. 2 times 7 is 14. 5 times 1 is 5. 3 times negative 3 is negative 9. 14 plus 5 is 19. 19 minus 9 is 10. And 10 is equal to 10. So it checks out in the first one, correct? So that means we have to go to the second one. 3 times 7 minus 1 plus 4 times negative 3. 7, 3, and 1. 3 times 7 is 21. Minus 1 is 20. Minus 12 is 8. And 8 is equal to 8. So it checked out in the second one. So we have to keep going to the third one. Whoa, hey now. Five times 7 minus 2 times 1 plus 7 times negative 3. 5 times 7 is 35 minus 2 minus 21. 35 minus 2 is 33 minus 21 is 12. And 12 is equal to 12. So yes, this ordered triple is a solution to that system. Okay? We got to check it in all three now. Just like we last week, we had to check it in both of the equations. We got to check it in all of the equations here. Okay? So today we are going to be solving a 3x3 system. A 3x3 system is 3 equations with 3 variables. Okay? 3 equations, 3 unknowns. For every unknown, you have to have an equation. So for every variable, you get an equation. So when we got 3 variables, we got to have 3 equations. Okay? So we're going to go substitution today. Tomorrow, I'm giving you an off day. Against my better judgment, I'm giving you an off day tomorrow. So nothing to do other than make sure you've got the formative at 100%. Make sure you got the 2 homeworks turned in for second semester. All that good stuff. Okay? Wednesday, we'll go with elimination. Thursday, we'll go with applications for 3x3. Okay? So, the steps for substitution. Step number 1, we need to pick a variable, pick an equation, and we got to solve that equation for that variable. Okay? Again, just like substitution last Monday, you want to be smart in your pick. Okay? So looking at this system of equations, which equation, which variable do you want to solve? X. Okay, that's the variable. Which equation?
I would just put X to the left side.
But so which equation did you pick?
Oh, the last one.
The last one, the third one. The third one, correct. Because they all have X in it. So I can't just say X. That's what I'm saying.
Sorry.
Okay? Yep, no, I got you. Okay? So you chose X, third equation for X. Okay? Smart choice. What's another smart choice? Second equation for Z. Or what's the other smart choice? First equation for Y. Yeah? Okay? So it doesn't matter which one we do. Okay? We can pick any of those. So Ms. Bailey said we're going to go the third equation for X. Just so we're all clear as to which one is which, I'll label them with Roman numerals. Okay? So we're going the third equation for X. So we should get X equals 7 minus 4Y minus 3Z. Is that what you got? You might have written it as negative 4y minus 3z plus 7. Okay, so that's I spied on the paper. Okay? Everybody agree with that? Love it. Step number 1, done. Step number 2 says, now we have to, whoa, cut the brakes, went too far. Step number 2 says, now we have to substitute that variable into the other two equations. It's got to go into both. It can't just go into one. It's got to go into both. So that would become 3 times 7 minus 4y minus 3z plus y minus 2z equals 10. And 6 times, probably won't be able to fit this in now. 7 minus 4y minus 3z minus 2y plus z equals negative 2. Get it in. Okay. We plugged it back in for x in the other two equations. Step number 3 says, now we've got two equations with two unknowns. So we're going to use either elimination or substitution on those. So first off, what we should probably do is we should probably say, well, this is 21 minus 12y minus 9z plus y minus 2z equals 10. So I would say there that that is negative 11y minus 11z equals negative 11. (42 minus 24y minus 18z minus 2y plus z equals negative 2. Negative 26y minus 17z equals negative 44. Negative 26, yes. Negative 17, yes. Negative 44, yes. Yep. Yep. So, substitution or elimination. Substitution, okay. Which equation for which variable? Left or right, y or z? Y, okay. Mr. Kopetsky, Ms. Bailey has chosen y. You choose the equation, left or right? Left one? Okay, that's what I would go to, because they all have negative 11 as their coefficient. Yep, that's exactly what I would have done too. Okay, so negative, oh, got the brakes. Apparently we didn't get blue yet. Negative 11y equals 11z minus 11. Divide everything by negative 11. That's going to give me y equals negative z plus 1. Plug that back in, my other equation. Negative 26 times negative z plus 1 minus 17z 4. 26z minus 26. Z equals negative 44. 26 minus 17. The 9? 9z. Equals negative 18, I believe. Right? 36 and 8 more is 44. Yep. So what's z? Negative 2. I know.
So much work.
So much work
For one.
for 1. But then, now what do we do?
Maybe.
Which, give me a color that we should plug it back into. No? Because we only have what? Or we only have z. What color should we plug negative 2 back into? Color. Color of the equation. Orange. Okay. Our choices are one of the 2 oranges, right? Or the blue one. Okay. So which orange? Left or right? Left one. Okay. Does it matter? No, it really doesn't. Exactly. Okay. So negative 11y minus 11 times negative 2 has to be negative 11. So that is negative 11y plus 22 equals negative 11. I get y equals 3. Okay? Now what? What's our next step? We got 2 variables. We had 3 to start. Find x by plugging it back into that original one that we solved for, right? Yepper. Okay? So plug those 2 variables back into any one of the original equations, and that's going to find you the other one. So let me jump back up here. I got to rewrite this one. X plus 4y z equals 7. And I can scroll on back down. So we got x plus 4 times y. Y is 3. Plus 3 times z. Z is negative 2. And that's got to be 7. A little purple. So x plus 12 minus 6 is equal to 7. So that's x plus 6 equals 7. So I get x is 1. Okay? So now, we've done all that work, right? What should we do? Now that we've done all that work, we got 2 things to do yet. We got to check it, and then how are we going to write our possible answer? X, comma, y, comma, z. Yep. So our possible answer is going to be 1, comma, 3, comma, negative 2. But what we have to do now is we have to check our work by plugging that back into the equations, and then we've got our answer. Okay? So our third one, only because I've got it written down here on the board. was that one. So then this would be 1. 4 times 3 is 12. 3 times -2 is -6. 1 plus 12 is 13, minus 6 is 7. 7 is equal to 7. Love it. I'm going to scroll all the way back up, and I'm going to write down the other two. And I'm going to scroll all the way back down. There we go. So 6x minus 2y plus z equals -2. 6 times 1 is 6. 2 times 3 is 6. So 6 minus 6 is that. Z is -2. 6 minus 6 is 0. Minus 2 is -2. And -2 is equal to -2. Checks out. Last one. 3x plus y minus 2z equals 10. 3 times 1 is 3. Plus 3. -2 times -2 is +4. 3 plus 3 is 6. Plus 4 is 10. 10 equals 10. Shabam. There is our answer. Okay? I am not going to lie to you. You might make a mistake somewhere along the line. That check is huge. Okay? Huge. Okay? What I would like you to do now is I would like you to try this system of 3 equations with 3 unknowns. Solve it using the substitution. From walking around the room, it appeared as if 100% in the room chose the third equation to solve for y. Okay? And I would agree with that. So I would get 6x plus 4z plus 1 equals y if we added y to both sides and added 1. Okay? It doesn't always have to be on the left. We can go to the right with it too. Okay? So then that's now got to go into in for y in both of the other ones. So 4x plus 2 times y plus 3z equals 1. And y is 6x plus 4z plus 1. And then at the same time, I got to put it into the other one. I saw a lot of people in the room trying to just plug it back into one equation. You got to put it back into both. Because I need 2 equations with both x and z. So let's work this one. 4x plus 12x plus 8z plus 2 plus 3z equals 1. 16x plus 11z equals -1 when we subtract 2. The only thing we're going to move is the 2. 2x minus 18x minus 12z minus 3 plus 5z is -14. Add 3. -16x minus 7z equals -11. Substitution is in play. Excuse me, elimination is in play, because if I rewrite that one over here, negative 16x minus 7z equals negative 11, and I add them together, x's go away, 4z equals negative 12, so z equals negative 3. Plug negative 3 back in. Negative 11. So that's negative 16x plus 21 equals negative 11. Negative 16x equals negative 32. X equals 2. Six x plus y was equal to 6x plus 4z plus 1. So y here is going to equal 6 plus 4 plus 1. X was 2. Z was negative 3. 12 minus 12 plus 1 is 1. So our possible point is 2, comma, 1, comma, negative 3. And now we just have to check it. 2 times 4 is 8. 2 times 1 is 2. 3 times negative 3 is negative 9. And that's equal to 1. Checks out. 2 times 2 is 4. 3 times, or negative 3 times 1 is negative 3. 5 times negative 3 is negative 15. 4 minus 3 is 1. Minus 15 is negative 14. Checks out. 6 times 2 is 12. Minus 1 is 11. Plus negative 12 is negative 1. Negative 1 is equal to negative 1. So, shabam, there is our point. Or our ordered triple. Okay? Questions, comments, concerns? Clarification. Okay? So, you can do numbers 1 and 2 from the week 21 worksheet. In Personers, that's numbers 1 and 2 on the first page of the packet that I handed out to you. Okay? On top of that, I am still waiting for people to do their formative from this past weekend. I am still waiting on people to do the 7 problems from last week. I'm still waiting on 12 people to do the week before's homework. The week before's homework is pretty much unacceptable that it's late, because that was 4 total problems and you had 4 total mods to get that done between now and then. Okay? That's unacceptable. No video tomorrow. Make sure you get your work done if you're one of those people. I am giving you ample opportunity to be on track, to be on pace with this class second semester. Okay? Take advantage of it, because we can do more examples during the day. I don't have to give you work time. We can do more examples.